Let's do example 22.10, which is going to show us another way of finding volumes of revolutions, this time not by taking a radius and spinning it around in a circle to generate a washer and then integrating those washers, but instead doing something like this called the shell method, where I have a height that I then spin around in a circle and it generates a sort of cylinder for me. And I can calculate the area of that cylinder, and then I can nest those cylinders like this to recover a volume. This example wants us to find the volume generated by rotating the region bounded by y is equal to 3x minus x squared in the first quadrant around the y-axis. So let's draw what's going on here. There's the y-axis, and this is a concave down parabola with zeros at 0 and at 3. So it looks something like this, and we are rotating around the y-axis. So usually we would draw lines like this and spin those lines in a circle and integrate with respect to y. Here, however, we're going to generate heights and spin those heights in a circle. So if I spin this height in a circle, it's going to generate a cylinder for me. And that cylinder, if I stretched it out, would have a height and a width, but the width would be that circle right there, the circumference of that circle. So 2 pi r. Now let's figure out what the height is and what the radius is. So the height of this cylinder is given to me by my function value. This is 3x minus x squared. The radius is given to me by how far that cylinder is away from my origin, away from the point that I'm spinning it. So this would be the x value. Right? That would be whatever the x value is. The biggest x is 3. The smallest it is 0. So the area of these shells will be 2 pi x, that's my radius, times the height, 3x minus x squared. So that right there is the area of the shell, and then we're going to nest these shells, starting with the smallest one at 0, and integrating all the way until x is equal to 3. So running through this real fast, we have the integral from 0 to 3 of 6 pi x squared minus 2 pi x cubed, which we can pull a 2 pi out of the integral and integrate from 0 to 3, 3x squared minus x cubed. An antiderivative can be x cubed minus 1/4 x to the 4th, which we will evaluate between x is 0 and x is 3. And skipping all the algebra, we should be good at evaluating antiderivatives by now. We have 2 pi times a 27 minus an 81 over 4, which simplifies down to a 27 pi over 2. So the volume found by the method of shells is going to give you the same thing as the volume found by the method of washers. It's just a different way to do it. You integrate with respect to a different variable.